Hello and welcome to the Cyber1 YouTube channel. In this video, the first of the series on Fred's brain, we're looking at the software. Now, we'll just go and do a bit of a recap on what's actually installed in Fred's head. There is quite a bit of stuff in there, and it does vary a little bit from robot to robot, but we'll cover Fred in detail on this one. So most Inmoov robots will have a pair of Arduino 2560s located on the back, typically with a Nervo board shield created by Gael Langevin, and that will distribute the various input-outputs via ribbon cables to various servos and sensors around the Inmoov body. There's two used because there's a lot of servos and sensors across the robot. I've gone a different route, putting the PCA9685 I2C 16-channel PWM driver boards. Adafruit listed them as a 16-channel servo driver. The PCA9685 chip was originally developed as an LED driver, but it was found that you could use them to drive servos by limiting the range. Now, with that in mind, these are an I2C device, so you can connect them to an Arduino, which is then connected to a computer running MyRobotLab, or if you are running MyRobotLab on a Raspberry Pi, as I am, you can connect directly to the I2C ports on the Raspberry Pi. Now, these boards are configurable on address, so you can put multiples of these boards on the same I2C bus. I have two currently installed in Fred and plans to install two more, one in each arm when I get around to installing his arms. If we have a look in the top of the head, you can see it's a non-standard build on his head, and I go into a lot more detail on the construction of this in the Fred's Head series, and I'll put a link to that playlist in the description. For a power system, I'm actually using a 20 volt DC bus running around the robot and using small switch mode power supplies to drop the voltage down to whatever's required. So in this picture you can actually see the larger 20 amp switch mode power supply, which is driving the PCA9685 and is delivering around 6 volts to it. And below that is a small 3 amp buck boost switch mode power supply, which is supplying power in this case for the network switch on this side, and also for a Raspberry Pi 3 and touchscreen on that goes over that opening. In the head, I've actually got two of these switch mode power supplies, one for the PCA9685 up there to run all of the servos in the head. During construction, that was it sitting there. And another one over here for the Raspberry Pi that was going in the head, and that's set for 5.1 volts to give it plenty of power. Originally I installed a Raspberry Pi 3 into the head of Fred, but later I replaced that with a Raspberry Pi 4, and I'll put links to all of those videos in there. One of the reasons for going with the 20 volt system was to try and eliminate voltage drop across the system, and Fred did a video on that covering the reasons behind using higher voltages to reduce currents and how current going through a wire produces a voltage drop. So I'm not going to cover that in this video. In this video we're going to look at the program that we're using. In Fred's Head Part 4, I installed MyRobotLab onto the Raspberry Pi, and while it's similar, it's very much the same for installing on the Raspberry Pi 4 as well as Raspberry Pi 3. In these videos, I'm going to be starting out with programming using the Manticore version of MyRobotLab, and We will then move on to Nixie when it's a little more stable. I have had some issues with loading or having scripts load the services for servos on the PCA 9685s under Nixie, but they work fine under Manticore, so we can start with that. There are some minor differences between Manticore and Nixie. It's advised to change the programming for them, but it's not a requirement. But we'll come back to that more when we look at servos. Because I'm running this on a Raspberry Pi, I have created a script to assist in starting FredUp. Launching from inside the MyRobotLab directory on the Raspberry Pi, this script, it'll clean all the logs and then it will launch MyRobotLab using the Java command. Now, there is a slight difference between the way we launch the Manticore version and the way we launch the Nixie version. So in this, I've commented out the launch for the Nixie version and I've got the launch for the Manticore version. When we switch to running Nixie, we will need to change that script. But in the meantime, this makes it easy to start FredUp. So let's go back and look in the list of Fred's programs. So this is all on GitHub, as you can see from this web page. You can download all of this as a clone copy, and for the most part it will work. You may have to change the configuration. So in this video, we're first going to go over the various files and the way it's split up and why I've split it up the way I have. The most important one for new users trying out this software is going to be the configuration. And because the configuration, there is a lot to configure in the configuration, I split it into multiple files in a subdirectory. And we have the sysconfig. So we're going to look at each of these files, and these files, the servos and the life functions, in more detail over the coming few videos. So let's have a look and see the Start Pi program and see how it looks. I've tried to comment a lot of these files as best I can to help people learning Python and MyRobotLab how it all works. One of the things that we wanted to do was keep all this programming in a separate directory within MyRobotLab, and I call that directory Fred. You can rename that directory, but if you do, you need to change this entry here. Let me highlight it. You need to change that to match whatever you name your directory as. This running folder is used throughout the program to select the name of that folder from the MyRobotLab directory. That's pretty much everything we'll be running. We have a useful function called execute file. Execute file will load another Python file in and execute it, and that stays in memory after you've run it. In this case, running folder, so that's going to be Fred, and in the subdirectory 1_configuration, I have a file called 1_sysconfig.py. It will execute that and load the system configuration file. The system configuration file prints out to the debugging on Python within MyRobotLab that it's creating the system configuration. And then we tell it which operating system we're using, whether it be Manticore or Nixie. Now I've done that mostly for the servo section, but if I come across other things that are different between Manticore and Nixie, we can also use that to change the programming to work with both. As I said, I'm starting with Manticore and I will change to Nixie when we get Nixie working. One of the headaches with changing between Nixie and Manticore is you've also got to reprogram the Arduinos that you have connected to work with that operating system, and that is a must. MyRobotLab has had for quite some time now 2 graphical user interfaces. One is Swing GUI, which is the one that runs on the computer itself, and then there's the Web GUI. Web can run on that computer, or it can run on a different computer. So it has advantages if you're running headless, as we do with the Raspberry Pis. The Web GUI is the preferred method in Nixie, and Swing GUI was the preferred method in Manticore. The Web GUI is, however, required when you're using WebKit speech recognition, and that uses Chrome for its speech services, recording and sending off to Google for translation into text, and comes back and you can feed that text straight into the AI program, in this case Program AB. We'll cover that in more detail when we get to that section. One of the things you can do when you launch the Web GUI is start it or not start it. In this case, we've configured it not to start the web browser at startup. I'm using this one in this case as a remote access, and for later when we do use WebKit. So let's go back to start. So after we load the configuration and we've printed, we're going to start the Fred MyRobotLab OS. This is where we check and see if we are actually starting the Swing GUI. If we are, we call the runtime, which is the core of MyRobotLab, and we start the GUI called Swing GUI. So this is actually the name of the service within MyRobotLab, and this is what we're going to call it in our tags, in this case GUI. Next, we're going to look at Web GUI, and we're going to see if we're going to be starting it up. And again, we do the same thing. We're calling this Web GUI as our service name, and it's called Web GUI in the service list, so that makes it easy to remember. CLI is, I think, the client size, and so it would try and open the client to 400 by 400. And if we don't want the browser to launch straight away, we set it to false, which we've done, and we set that. Then we start the web service. In the case of the Swing GUI, we actually started it straight off the bat, whereas we only created it for the Web GUI. Right, next we're going to load in our controllers Pi. First thing we do is load in the configuration within controllers. So in controllers, we have a look at we set the configuration, are we running a Raspberry Pi? And this is either true or false. I am running a Raspberry Pi in Fred, so we're going to set that to true. If you're running this on a PC or a Mac, then you are going to be setting this one to false. Now, if you're running a standard build Inmoov Robot with the 2 Arduino 2560s located on the back, you will need to set the left and right Arduinos to true. I'm not running those, so I set them to false. Where it's got the Arduino left COM port or Arduino right COM port, this is the communication port that is created when you plug the Arduino in. On a Linux-based system, it will be dev TTY USB 1, 2 or 0. On a Windows machine, it will be COM and a number, COM3, COM13, COM10. So you'll have to check that each time you plug one in just to see what it comes up as. The good news is most of the time they will come back with the same port each time. I'm running a Arduino Nano in the chest of Fred, which I've shown in a previous video. Again, the link will be in the description. And that comes up as TTY USB 0 on my Raspberry Pi. So I've got it set to true for I'm using that Arduino Nano and the device address that I'm using. The next level of controllers that we use, again this is optional depending on the build you're running, is the PCA 9685s. In MyRobotLab they call them the Adafruit 16C servo driver, and I've got 4 of those defined. At the time of recording I didn't have the arms on, so I've only got the head and the back installed. At a later date when I've got the arms on, I'll have the next 2 turned on. If you're running a Nervo board configuration, you probably won't have these, and so you set these to false and you don't need to worry too much. If you do, if you're running a PC and you've got an Arduino installed, you can connect these to the I2C port on the Arduinos, in which case you'd need to tell it which Arduino you've got it connected to. The driver port would be 0, and of course the address that your PCA 9685 is set to. The last thing that you may install, and I haven't yet on mine but plan to, are inertial measurement units. MyRobotLab supports the MPU 6050 out of the box, so we can actually use that. You can configure up to 2 of those on a single I2C bus. Because I've got a Raspberry Pi Nano, an Arduino Nano installed, I can actually use the I2C bus on that to get 2 more of these if I need them. So that covers the configuration file. Let's have a look at the controller itself. And in the controller we've got Enable Raspberry Pi, and this is where we start the runtime for the Raspberry Pi if we've enabled it. The next one we've got the Arduino left and the Arduino right. Again, same story, all the information is taken from the configuration file, but we'll have a look at it with a little bit more detail. So runtime start, Arduino left is the name we've called the service. Arduino is the service within MyRobotLab, so you can actually start multiple services of the same type. So in this case we've got Arduino left, Arduino right and Arduino Nano are all separate services using the same MyRobotLab service. Set the board Mega, set the board Mega, set the board Nano, so we're actually defining the type of Arduino that we're going to be using, and then we set the COM port and connect to it. With our I2C devices, with the one for the head, the Adafruit 16C servo driver for the head, when set to true as I have, we create and start the head using that servo driver, and then we attach it to the appropriate port, whether that's be on the Raspberry Pi or on Arduino, and that's set in the configuration. We go back here, there's your configuration setting there. And we do the same sort of thing with the MPU 6050. We've got A and B for the 2 that we can potentially have. I've only allowed for 2 within the configuration, but you can add more into the controller files and add more into the configuration. One of the things by doing all of this in Python is we can expand it when we need to. Okay, so that will do for this video. If you enjoy these videos, please click on the like, consider subscribing and ringing that notification bell so that you know when the next video is released. I have a Patreon account. I'd like to thank Go Lucky, my #1 Patreon, and you might want to think about supporting as he does. I have a Discord channel, and there will be a link to that in the description, so that if you need a little bit of help or if you have any suggestions, come on over and let us know what you think, and we can work through and maybe add that into answers on more videos. If you do have questions, you can also leave comments in the video, and I do try and read them all and get back to people. And we'll see you in the next video.